Myself, Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department in Institute of Aeronautical Engineering, Hyderabad. Myself, today I am going to teach the electromagnetic field theory. Electromagnetic field is the base of the total electrical engineering like power system machine. And today I will start the prerequisite or the fundamental of the introduction to vector algebra. So what is the course outcome? First we will discuss what we will study in this subject. Use the vector calculus and other informations and mathematical techniques to describe the electromagnetic phenomena. This is the course outcome of this subject, and according to the Bloom taxonomy, this comes under apply Bloom's taxonomy. So while we are starting, we will discuss what is field, what is the meaning of electromagnetic field. All of we know that field means the space. Field is a space. We are going to play in the field. What is that field? Field is nothing but a space where we can do something. According to the definition, a field is a function that specifies a quantity everywhere in the region. If we told about the electric field, means in that region, if we keep one positive unit charge, it can feel some force. So this is the field. And according to the another definition, a field is a spatial distribution of quantity. What is field? Field is a spatial distribution of a quantity. It can be either scalar or vector. What is the meaning of scalar field? See, we are measuring the temperature. Some hot area is there. So temperature is a scalar field. Some field is the vector field. What is the meaning of the vector field? It has certain direction, like the electric field, electromagnetic field. These are the vector field. So now we will discuss about the classification of electromagnetic field. Our subject name is electromagnetic field. So first we will discuss what is the different types of electromagnetic field. So we can tell the field in the electrical engineering or as an electronics engineering, we can broadly divide it into the three parts. First part is the electric field. Electric field is due to the electrical charge. See, we have a capacitor. We are connecting to parallel plate with some positive and negative open battery. So in the between of this parallel plate, if we keep some electrical line, it will feel some force. So this is the electrical field. Next one is the magnetic field. Magnetic field means if it is in the north and another is the south of a magnet, and we keep some another magnet in between the two magnets, it will feel some force. I think that everyone has done this experiment in their class 12, that if there is two magnets, we keep it, one is north side and another is the south, and if we keep some magnet in between them, it will feel some force, and this area is known as the magnetic field. Now another important thing is the electromagnetic field. What is the meaning of electromagnetic field? Electromagnetic field means it is a combination of electric field as well as the magnetic field. And the best example is the DC motor. We can draw, say this is a pole and this is the another pole. If we take a two-pole machine, north pole and south pole, we give some connections on the iron and it will be changed into the electromagnets. Now we know from north pole to south pole, this is some electric lines of forces, or we can tell it as a we can tell it as a electric field. So this electric field we can tell is the electromagnetic field. Why electromagnetic field? It is a combination of electric field and magnetic field. We are giving current to the iron and iron is changing into the electromagnet. So this is the example and it is maybe two types. One is the time independent and another one is the time varying. For simplicity we can tell, if we give the DC source to the iron, we will get some field which is a time independent or time constant. If the supply is AC, we can tell it as a time varying field. So field is basically three types: electric field, magnetic field and electromagnetic field. First we will go, so before starting the basics of the field, we will start about the vector algebra, which is the main aim for today's class. So what is when we are telling about the vector, the another word comes in our mind and that is nothing but a scalar. What is a scalar quantity? A scalar quantity means it has only the magnitude but no direction. It is a physical quantity that only has the magnitude but no other characteristics, means it don't have any direction. What is the example? Temperature. Temperature has only the magnitude. If we tell 20 degrees centigrade, it means a temperature. It has a magnitude but there is no direction. If we tell mass, it is also the magnitude. Electrical charge 5 coulomb, this is also only magnitude. Another important thing is the speed. Speed means if I tell a car is moving in 50 km per hour, what does it mean? It means it has certain magnitude but it don't have any direction. So this is the scalar quantity. Next is the vector. So what is a vector quantity? Vector quantity means it has both direction as well as magnitude, is called the vector. And what is the example of vector? Force, electric field, velocity, like this. If we think about the speed and velocity, what is the difference? If a car is moving with 50 km per second, this is the speed. It has a magnitude. It has a magnitude, but it don't have any direction. But if we tell the car is moving 50 km per second from north to south, so it has certain direction, and this is known as the vector. So in the vector we can see this is a magnitude it has and it has a direction. Actually we give the direction from the tail to end, means from the starting point to the end point. This is the general nomenclature to write a vector. We can write the vector like A. So like this we can write one vector A. So what we can write, if we write A, B. So something is moving from A to B. Starting point is A and end point is B. So this we can tell the vector quantity. In the electric field, north to south, positive to negative, so it has certain direction. Force, if we think about the gravitational force, what is the direction? It is downwards. So these have all the direction. This is magnitude and a direction. Now as I have told that this is a car and you can see this car. I have already given the example. So in the car, there is a speedometer. We can see the speed. And what is the speed? The speed is a scalar quantity. We don't know the value of the speed, But when the car is moving in a certain direction, and it is called the velocity, and velocity is a vector. Next, we will discuss about the unit vector. This is a very, very important thing in the electrical engineering. What is unit vector? Sometimes we do not know the value. So, say we are telling about the velocity. We are giving the same example. A car is moving from north to south. Okay, so this is a vector quantity. Now, say from first 5 kilometer, it has a speed of 50 kilometer per second. Next 5 kilometer, it has a speed of 60 kilometer per second. So magnitude can be variable, but it is going from north to south. So when we are thinking about a broad aspect, we can tell any vector to the unit vector. And unit vector has two parts. One is direction, another one is the magnitude. But the magnitude is always 1 in the case of the unit vector. When we are thinking about the unit vector, the magnitude is always 1. But it has a certain direction. So it has a certain direction. Its magnitude may be 1, but it has a certain direction. How we can write a unit vector? Generally, unit vector can be written with a lowercase letter, with a cap symbol. What does it mean? Say we have a vector A. So this is a vector. If we want to write the unit vector of the A vector, we can write it with A hat, A cap. It will be in the small letter and there should be a cap or hat. So a vector can be represented in space using the unit vector. What does it mean? You can see the x, y, z axis. So if anything is moving through the x, we can tell it is have a value of the x. I, we can write it by I. If anything is moving along the y-axis, the direction can be written as j. And if anything is moving as the z-axis, we can write it as the k. So we can tell that if anything is moving in the electromagnetic field, we will only concentrate about the three-dimensional thing. So three-dimensional means three axes, x, y and z. So anything is moving means it has moving in three-dimensionally. X, the unit vector has been written by I, and sometimes we can write it by AX. Generally in the electromagnetic, in physics, we use the I notation. Okay. So in the unit vector, we can write it as the I notation, whereas in the electromagnetic field, we will write it by AX. Something is moving in the X. Next is the AY. Something is moving in the Y direction. And AZ. Something is moving in the Z direction. And we can write the unit vector by A hat is equal to A by mod of A. How we can write? We can write an unit vector by the total vector divided by its magnitude. Let's do one example. Say A vector is, I will write 4x cap. So means its magnitude is 4 and it is going through a direction by x hat. So what is 4 is its magnitude. 4 is the magnitude and x means it is going through a direction in the x. So what will be the unit vector? Unit vector can be written as A cap, and A cap is equal to, according to the definition, it is A by mod of A. What is A here? A is 4x hat divided by its magnitude. Which one is the magnitude? Magnitude is 4. So we can write as x. So we can write it as the x hat. Next one is the position vector. What is the meaning of position vector? Position vector means, as I told earlier, now from today onwards, we will write everything in the x, y, z axis in the 3-dimensional. Already up to your first year syllabus, up to your second semester syllabus, you already know about the position in the xy plane. If we write a point what does it mean? The point has a magnitude 2 along the x-axis and its magnitude is 3 along the y-axis. So, position vector means x-axis, y-axis. If we think about the 3D, it should have x, y and it should have some x, y and z axis. So this is called the position vector. X, y, z. 3 axis for a 3-dimensional thing. Say, if in this figure, if we give one point, if in the previous one, if we give one point P, if we give one point P, 2, 3, 4, so what will be its position vector? We can write in 2 nomenclature. According to the physics, we can use I, J and K. So first one is the X. So we can write as 2I cap plus 3J cap plus 4K cap. Otherwise, we can write it as an x-axis also. How? 2ax cap. In the electromagnet, we will write 2ax plus 3ay cap plus 4az cap. So, this is the position vector. So, this is the position of a vector. We can write it in the x, y and z. So, let's do some example. Find the unit vector in the direction of A 4, 3. So, A point is in a 2-dimensional. If we think A 4, 3 means A is a 2-dimensional. So, this is the point A. And what is its location? 4, 3. So, what will be its value? Its position vector? Its position vector will be 4. First one is the x-axis. So, 4ax plus 3ay. So, A vector is at 4ax plus 3ay. You can say, if it is in the x-axis, we can also write according to the physics 4i plus 3j. This is the point. So, what is the magnitude of the point? What is the magnitude? How to calculate the magnitude? So, the point A is 4, 3. So, how to do the magnitude? If we go to the previous slide, we can see it is 4 in x and y 3. So, its magnitude is the diagonal. So, what is the magnitude? Magnitude of A is basically root of 4 square plus 3 square, and the value is 5 unit. And if we know the magnitude, according to the definition of the unit vector, what is the unit vector? We will write it with a lower case with the cap on it, and according to the definition, the A vector divided by its magnitude. So what is the A vector? A vector is, already we have written here, what is the value? 4ax hat plus 3ay hat, and what is the magnitude? Magnitude is 5. So this is our unity vector. Now one may ask me, how you can tell it is an unity vector? We can see there is some value. So how you can tell it is an unity vector? So what is the value of unity vector we got here? We got here 4 by 5 ax hat plus 3 by 5 ay hat. So we have this vector, we have some coefficient also. How we can tell it is an unity vector? So according to the definition, unity vector means it has some direction, and we know the direction now, and it has some magnitude, and magnitude is always 1 or unity. So let's check the magnitude. So the magnitude is root of 4 by 5 whole square plus 3 by 5 whole square, and it is root of 16 plus 9 means 25 by 25, and the magnitude is 1. So you can see, whatever the unity vector, the magnitude is always 1, but it has a certain direction. And as I told, we can write ai is equal to ax, j means y-axis, we are writing it as ay, and z is by az. Okay, so next slide. So we will go to for another example of the unit vector. So now we are taking the unit vector in a 3-dimensional space. So in the 3-dimensional means, generally we write it x, this is our y and z. And one point is here at 4, 3, 2. So what will be the position vector? Position vector will be 4ax hat plus 3ay hat plus 2az hat. According to the first one is the x-axis. So it is 4ax hat plus 3ay hat plus 2az hat. So what will be the magnitude? Magnitude will be similarly same thing. Coefficient of x square plus coefficient of y square plus coefficient of z square. Let's write 4 square plus 3 square plus 2 square. So it is root 29. So what will be the unit vector? Already we have told the definition. Unit vector will be written by small a and cap on it. And what is the definition? Definition is unit vector means total vector by its magnitude. So what is the total vector? Total vector is vector A. What is the vector? Vector A by its total magnitude. So what is A vector? Already we got in the first line 4ax plus 3y plus 2az. And what is its magnitude? Its magnitude is root. Its magnitude is root 29. And again, how we can prove this one? We can calculate the magnitude of A, and it is coming 4 by root 29 whole square. What is the magnitude? Magnitude means coefficient of x square plus coefficient of y square plus coefficient of z square. Coefficient of x square is 4 by root 29 whole square plus 3 by root 29 whole square plus 2 by root 29 whole square. So this value is coming 16 plus 9, 25 plus 4, root 29. So this is 29 by 29, and we got the magnitude unity. So I think now it is clear what is unity vector. So unity vector means the vector divided by root the modulus of the magnitude of the vector. And how to calculate the magnitude of the vector? Square root of coefficient of x square plus coefficient of y square plus coefficient of z square. Now we will come to the vector algebra. Today's lecture we will discuss about this vector algebra, scaling, addition and subtraction, and third one is the product. And product is basically two types. One is called the dot product, another one is known as the cross product. So today we will start with the first, scaling. What is the meaning of scaling? Scaling means multiplication of a vector with a scalar quantity. Means if we want to increase the value, say current in one line, some current is flowing and the value of the current is 5 amps. It has certain direction. If we change the value, if we increase it double, so we are multiplying but we are not changing the direction. What does it mean? We are multiplying the vector with a scalar quantity. So you can see first one is the A vector and we have multiplied with the alpha. Alpha means some scalar quantity. You can see also this is a vector A. We are multiplied it. We want to decrease it. Decrease means we are doing some multiplication which is less than 1. Another thing is, if we want to change the direction, means we can, so in the direction we can multiply with -1. Multiplication with -1 means we can change the direction. We will do one normal example. So if we have a vector A 4, 3, 2, same thing we are taking. First we have to make it a double. Double means we just want to change the magnitude. What will be the value? A will be x up will be double means 8. Y will also double means 6. Z will also double means 4. So all the position will be doubled. And what will be its position vector? Its position vector will be, position vector means ax plus ay plus az. So what will be the position vector? 8ax plus 6ay plus 4az. So this is the position vector of A. So double means, scaling means we are just simply multiplying the vector with a scalar quantity. Now addition and subtraction of a vector. In class 12 physics, just remember, this is a simple thing. How to add two vectors? If two vectors are acting simultaneously on a point, if two vectors A and B both are acting simultaneously with a point O, what will be the resultant? How to add this? We will just draw the diagonal from that point. We will draw the diagonal of this point and we will use the parallelogram law. Using the parallelogram law, we can add 2 points, and according to this, C vector is equal to vector A plus vector B. It will always follow the parallelogram law. And if we want to do the subtraction, how we will do the subtraction? See, we want to do the calculation from the same one A, B. We want to calculate the A, C equals to A minus B. So how to calculate this A minus B? We have the B vector, we will multiply with minus 1. Example of scaling. B vector we will multiply with minus 1. What will happen? Its direction will be in the opposite direction. Now, similarly, we will calculate using the parallelogram law, we can calculate the diagonal value, and diagonal is the resultant or subtraction of two vectors. So, if two vectors acting simultaneously on a particle are represented in magnitude and its direction of two sides of a parallelogram, we can calculate the resultant using the parallelogram law by drawing the diagonal. But it is another method of addition of two vectors. If there is two vector A and vector B, and vector A is given by AX, the magnitude is in the X direction is AX, magnitude is in the Y direction is AY, and Z direction AZ. This is our A. A has 3 magnitude in X direction AX. In Y direction AY and Z direction AZ. And we have another vector B. And the magnitude of B we are assuming BX in X direction, BY in Y direction, and BZ in Z direction. So, if we want to calculate A plus B, what will happen? X component will be added with X component, Y component we will add with Y component, and Z component we will add from the Z. So, X component will be added with AX will be added with AX, AY with AY, and AZ with BZ. So, this is the simple, and this is the main importance of the unit vector. If we can write a vector in their unit vector form, then only we can utilize this addition of two vectors method. That is, X component of AX will be added with AX, BX, the AY will be added with BY, and AZ will be added with BZ. So this is the addition of two vectors using the unit vector criteria. Okay. Another thing, if we want to do the subtraction, though I have not mentioned here, if we want to do the A minus, if we want to do the two things, A minus B. What does it mean? This is just opposite to the addition. So AX should be AX minus BX. So X component of AX will be subtract from the BX because A minus B, AX minus BX. AY minus BY. AY direction is in along the y-axis. And what is Z? Z will be AZ minus BZ. So these are the normal addition and subtraction using the unit vector. Now we will go for the product. So already we have completed scaling. Scaling means multiplying a vector with any scalar quantity. Next we have done addition and subtraction. Now third point we will do the vector multiplication. So what is the meaning of vector multiplication? Vector multiplication means we can multiply the vector in the two categories. One is called the dot product, another one is called the cross product. And what is the difference between dot product and cross product? Dot product means if we multiply two vectors and the result is a scalar quantity. So this is called the dot product. Dot product is if we multiply two vectors but the output is a scalar quantity. We will give one simple example. The example is work done. What is the meaning of work done? If we give some force to anything and if it has a certain displacement, if we are giving some force to something and it has some certain displacement, we can do, this is the work done. So mathematically we can write force. Force has a certain direction. It is a vector quantity. Dot, we will write with dot S. What is the meaning of S? S is the displacement. So F dot S we can write is a work done. And work done is a scalar quantity. So if one vector is A, another vector is B, and the angle between them is theta. The angle between them is theta. If the angle between them is theta, we can write the dot product as A, B cos theta, where A is the magnitude of A vector and B is the magnitude of B vector. So what is cross product? Dot product. Dot product is a multiplication of two vectors and the resultant is a scalar quantity. And we can write, if we write A dot B, what is the value? A dot B is equal to mod of A, magnitude of A into magnitude of B cos theta. We can take another example, power. What is the power in power? Active power, V I cos phi. V dot I. As an electrical engineer, we can take another example of power. Power is equal to V dot I. V modulus of V mod of I cos theta. And what is cos theta? Cos theta means the angle between voltage and current, and we can tell it as the power factor angle. So what are the properties? The properties are, if A and B both are parallel, means we have two vectors A and B. If we have two vectors A and B, both are parallel to each other. So what is the angle between them? The angle is 0 degree. And we know according to the dot product, I will write the formula once. A dot B is equal to AB cos theta. So we can tell cos theta parallel means theta equals to 0, cos 0 equals to 1. So we can tell it A dot B. Okay, A dot B is equal to mod of A plus mod of B. Now we will go to the second point. If two vectors are perpendicular to each other, angle is 90 degree. What will happen? If the angle is 90 degree, that means cos 90 is 0, and the total dot product will be 0. Let's give one example. This is also from your childhood example I will give. We tell when a person taking a bag in her hand walking somewhere, we will tell the work done is 0. Why? When one person is taking a bag in his hand, what is the angle with respect to the ground? It is basically 90 degree. And cos 90 is 0, means work done is 0. Third point, the dot product always obeys the commutative law. What is the meaning? A dot B is equal to B dot A. As the result is a scalar quantity, it doesn't depends on the direction of the vectors. And last point is, it obeys the distribution law. What is the meaning of distribution law? B plus C, if we add two vectors, and if we do the multiply with another vector A, so we can write A dot B is equal to A dot C. And this is the very, very important one. I dot I. What is the meaning of I? Or we can tell it AX dot AX. We can also write it AX dot AX. So similarly, if we take the vector in the both are in the x direction. Say we have I will draw it small. X, Y, Z. So in the X, Y, Z, say we have two vectors, two curves, both are running through the x-axis. So what is the angle between them? 0. And according to the cos theta, and these are the unity vector. What is the magnitude of a unity vector? It is 1. So 1 dot 1 cos 0. What we can write? The magnitude is 1 dot 1 cos 0. Cos 0 is also 1. So we can write I dot I is equal to J dot J is equal to K dot K equals to 1. Similarly, if two curves are moving to the Y direction, AY dot AY, if we write AY dot AY, magnitude is 1 as this is unity vector and angle between of them is 0. So 1 cos 0. So we can write this is also 1. If we go for the Z axis, again magnitude is 1 the value is also 0 as both are going. So we can write AZ or KK in physics, and in here we can write AZ is equal to 1. Now, if we think about the this is our x-axis, this is our y-axis, this is our z-axis. So, if anything is going from x to y in the anti-clockwise direction, what is all the axes are 90 degree to each other. So, x to y means ax or I dot j. We can write I dot j, or we can write ax. We can write it as an ax into ay. So magnitude is 1, 1, 1. What is the angle between them? Angle is basically 90 degree. Cos 90. What is the value of cos 90? It is 0. So the value is 0. Say anything is going from y to z. Y to z. So we can write j dot k, or we can write ay to az. 1, 1 cos 90 degree. It is also 0. Similarly, we will get from z to x. So, if the direction is the cross position, means I to j, x to y, y to z, or z to x, the value of the dot product is equals to 0. Similarly, if we take it in the anti-clockwise direction, this is anti-clockwise direction. If we go in the clockwise direction, what will happen? Ax, ay, we are going from ay to ax. Ay to ax. So, what is the angle? Angle is minus 90. Again, cos minus 90 is equal to 0. So, whatever the direction, if two vectors are 90 degree apart, the angle between them is 90 degree, it is 0. So, whatever I told, that if two vectors are A and B are expressed in unit vector notation, we can write AXI plus AY plus AZ. Another one is BX plus BYJ plus BZK. So, X terms will be multiplied with X terms, Y terms will be multiplied with Y terms, and Z terms will be multiplied with Z term. And there is no direction. Why? Because if I is multiplied with j, it will be 0. If I is multiplied with k, it will be 0. So, these terms will cancel out each other, and we will get ax bx plus ay by plus az bz. We will do one example of two vectors. A is equal to given and b equals to given. Find the dot product and angle between two vectors. So, we will do a term will be multiplied with a term. So, 2 will be multiplied with 3 and we will get the value 6. Next, in by, is 5, by is 5. So, the value is minus 25 because this is minus 5. Remember this thing, when we will multiply along with its plus or minus sign, not only the magnitude. We will take its symbol also. Next, minus 4 into 2. So, we will get the value 8. 6 minus 25 minus 8. So, the value is coming minus 27. So, already we got the magnitude. How to got the direction? Now, what is the magnitude of mod A? Magnitude of mod A, we already know how to calculate the magnitude. coefficient of x square plus coefficient of y square plus coefficient of z square. So we can multiply root of mod of a is 2 square plus 5 minus 5 square plus minus 4 square. It is coming root 45. What is mod b? 3 square plus 5 square plus 2 square, and it is coming root 38. So we know the formula A dot B equals to mod of A mod of B cos theta. So what is the value of cos theta? Cos theta is equal to A dot B by mod of A mod of B. So A dot B value we have calculated already, and it is minus 27. We have already calculated the mod A, which is root of 45, mod B root of 38. So if we put the value, we will get cos theta value. So this is the example. Now we have came to the last part, that is the cross product. So what is the cross product? Unlike the dot product, cross product means we are doing some multiplication and this result has some direction. So if we multiply two vectors and the result has some direction, the result is an in vector, we can call it as a cross product. And in the cross product, it has some direction and it always follow the right hand screw rule. If we have two matrix A, B, so A to B means we will take our right hand and we will roll our right hand from first matrix to second matrix, and the direction of the thumb will gives the direction of the resultant matrix. Say if we write the B cross A means from B to A, here from B to A, B to A means it is going downwards. So we have to check the direction. Direction always follow the right hand screw rules and the direction will be on the upward side. And according to the cross product, A cross B equals to AB sin theta AN. So if again similarly we will discuss some same formula. If two vectors are in parallel, if two vectors are in parallel, say this is one vector, this is one vector, what is the angle between them? The angle is, say this is our A vector and this is our B vector. So they are parallel. So if two vectors are parallel to each other, what will happen? The value will be A cross B equals to 0. As the angle is 0 and the formula is sin 0. So sin 0 is equal to 0. Next, if two vectors are perpendicular to each other, so the angle is 90 degree. Angle is 90 degree means, what does it mean? Angle is 90 degree means sin 90. So A cross B equals to AB. One more thing, we should always give the AN. What is the AN? AN basically the direction of the resultant vector. And why N? N means normal. If two vectors are in the XY plane, you can see this floor is the XY plane. So if anything is in the XY plane, the output is upward. Upward means this is the Z direction. Means normal to the plane. That's why we wrote it by AN. Similarly, the cross product is anti-commutative. What does it mean? A cross B. If two vectors are there, A cross B is from A to B. The direction is upward. But if we do B cross A from B to A, the thumb is in the downward. So we can write A cross B is equals to minus of B cross A. So A cross B is not equal to B cross A. That's why it is called anti-commutative law. So this is the another important characteristics or property of cross product. Next. So how to multiply? In the case of the dot product, it is very easy. But in the case of the cross product, multiplication of two unit vector is very tough. Why? See, we are multiplying AX dot AX means two vectors are parallel. What we can write? 1, 1, sine 0. Sine 0 means it is 0 and the result is 0. So if two vectors are parallel, the cross product is always 0. If we write AY cross AY, 1, 1 sine 0 means it is also 0. So I think this is clear to all. Now if two vectors are, so again say we have the multiplication AX to AY, AX to AY, so direction is upwards. So AX cross AY will be always AZ. So if we go in the clockwise direction, anti-clockwise direction, the resultant direction will be positive and it is in the upward direction. AY to AZ, AY to AZ. So the direction is in the AX direction. AZ to AX. So it is also AY direction. So always the direction will be perpendicular to it. Now it goes to the anti-clockwise direction. Now if the vectors are going in the clockwise direction, what will happen? It will happen in the opposite dik. Why? AZ to AX, AY to AX. You can see AY to AX. The thumb is in the downward. So if we write AY into AX, the direction will be minus AZ. Clear? So if we wrote AZ cross AY, it will be minus AX. So if we go to the clockwise direction, the result will be in the negative, and if we go to the anti-clockwise direction, the result will be in the positive direction. So for this only, for this we write it in the top X, Y, Z, then AX, AY, AZ, and we will do this. We will complete the value. The determinant of this matrix is the cross product. So already I have told this I cross I, J cross J, K cross K is equal to 0. If we go in the clockwise direction, we will get the positive normal plane, normal resultant, and if we go to the clockwise direction, we will get the negative side. Anti-clockwise positive, clockwise negative. So thank you all.
Like, share and subscribe. Hit the bell icon for more updates.